Hello friends, let's start off with exercise 2.1, chapter 2, relations and functions. So what is given in the first question? Now the concepts of relations and functions is given in the description, the video which is given in the description. Please look into that so that you can see what are all the concepts and what are all the formulas. We'll directly go into the problem right now. So if x by 3 plus 1 comma y minus 2 by 3 is equal to 5 by 3 comma 1 by 3, find the values of x and y. So now in the solution part, what do we have here is x by 3 plus 1 comma y minus 2 by 3 is equal to 5 by 3 comma 1 by 3. So we have to find out the values of x and y. Means what do we do is, since we are given that x by 3 plus 1 comma y minus 2 by 3 is equal to 5 by 3 comma 1 by 3. Now this is the ordered pair which we are having, and you know that in ordered pairs, when are two ordered pairs said to be equal? That is, if the first element of this first one is equal to the this ordered pair is equal to the first element of the second ordered pair, which is equivalent. Both these ordered pairs are equal when this first is equal to this first and when the second one is equal to the second element. So therefore the corresponding elements should be equal as the ordered pairs are equal. So therefore we have x by 3 plus 1 is equal to 5 by 3. Now taking the LCM on this left hand side, x plus 3 is equal to 5 by 3. Since the denominator is same on both sides, you can cancel it out. Therefore you are getting x plus 3 is equal to 5, which implies that x is equal to 5 minus 3 on both sides. So therefore you are getting f minus 3, which is equal to 2. So therefore we got x is equal to 2 now. Now the next one is what? We have y minus 2 by 3 is equal to 1 by 3. So now here also, if you take out LCM, here you are getting this as 3y minus 2 is equal to 1 by 3. So now we can cancel out 3 on both sides, therefore which implies that 3y minus 2 is equal to 1, which implies you can add 2 on both sides. So therefore you get 3y is equal to 3, which implies y is equal to 3 by 3, which is equal to 1. So therefore if you take this as 1 and this as 2, from 1 and 2 we have, from 1 and 2 we have x is equal to 2 and y is equal to 1. So these are the answers. Now going into the second problem. Second problem is, if the set A has 3 elements and the set B has 3, 4, 5, this also has 3 elements, then find the number of elements in A cross B. So now here you have that given. What is given in this problem? Given that set A has 3 elements. So therefore the number of elements in set A denoted as n of A is equal to 3. So we are having n of A is equal to 3. Now here set B has equal to, what is set B equal to? Set of all 3, 4 and 5. So here number of elements in set B, number of elements in set B denoted as n of B is equal to 3. So you can see 3, 4, 5 are 3 elements. So therefore it is equal to 3. Now therefore the number of elements in A cross B, the number of elements in A cross B denoted by n of A cross B, the number of elements in A cross B denoted by n of A cross B, the number of elements in A cross B denoted by n of A cross B, the number of elements in A cross B denoted by n of A cross B, the number of elements in A cross B denoted by n of A cross B, the number of elements in A cross B denoted by n of A cross B, the number of elements in A cross B denoted by n of A cross B, the number of elements in A cross B denoted by n of A cross B, the number of elements in A cross B denoted by n of A cross B, the number of elements in A cross B denoted by n of A cross B, the number of elements in A cross B denoted by n of A cross B, the number of elements in A cross B denoted by n of A cross B, the number of elements in A cross B denoted by n of A cross B, the number of elements in A cross B denoted by n of A cross B, the number of elements in A cross B denoted by n of A cross B, the number of elements in A cross B denoted by n of A cross B, the number of elements in A cross B denoted by n of A cross B, the number of elements in A cross B denoted by n of A cross B, the number is equal to number of elements in set A into number of elements in set B. So therefore n of A cross B is equal to 3 into 3, which is equal to 9. So therefore the number of elements in A cross B is equal to 9. So going into the third problem, if G is equal to 7, 8 and H is equal to 5, 4, 2, then G cross H, the Cartesian products G cross H and H cross G we have to find out. So we are solution for this third problem. You are given that G is equal to 7, 8 and H is equal to 5, 4, 2. So now how do we write G cross A? The Cartesian product of two non-empty sets A and B is given by or is given as A cross B is equal to A comma B. A belongs to set A and B belongs to set B. So this is how we define the Cartesian product of two non-empty sets. So therefore here you can see what is G cross H. Will see G cross H is equal to 7 comma 8 cross 5 comma 4 comma 2. So now how do we write this? We'll see, which is equal to, the first element will be from the first set and second element will be from the second set. So 7, 5, 7, 4, 7, 2. Then we have 8, 5, 8, 4 and 8 comma 2. So this is the answer which we get for this. Now next, what is H cross G? We'll find out. H cross G is equal to 5, 4, 2 comma 5, 4, 2 cross 7 comma 8, which is equal to, in braces, 5, 7, 5, 8. Then you have 4, 7, 4, 8. Then we have what is 2, 7, 2, 8 comma 2, 8. So therefore this is the third problem. So going into the fourth problem, state whether each of the following statements are true or false. If the statement is false, rewrite the given statement correctly. So therefore first one, what we have, if P is equal to Mn and Q is equal to Nm, then P cross Q is equal to Mn comma Nm. Is this true or false? We'll just see. So solution for this. So now here you are having P is equal to Mn and Q is equal to Nm. We'll see what is the Cartesian product of P cross Q, which is equal to M comma N cross N comma M, which is equal to Mn comma Mm comma Nn comma Nm. So here you are getting 4 elements over here, 4 ordered pairs, but it is given that P cross Q, but it is given that P cross Q is equal to set of all ordered pairs of M comma N, N comma M, and which is false, since this one it is not equal to the above one, therefore incorrect or false, and the above statement can be rewritten as in equation 1. second one. What is the second one here? If A and B are two non-empty sets, then A cross B is a non-empty set of ordered pairs xy such that x belongs to A and y belongs to B. So therefore this is absolutely true. Since you have A and B are two non-empty sets, then A cross B is equal to set of all xy such that xy is equal to x belongs to A and y belongs to B. So therefore it is a true statement. Now third one. What is the third one given to us? Third one is if A is equal to 1 2, B is equal to 3 4, then A cross B intersection phi is equal to M. Given A is equal to 1 2, B is equal to 3 4. To prove A cross B intersection phi is equal to phi, we have to prove this. So therefore now you have B intersection phi is equal to 5. We have seen the concepts. I proved that B anything into an empty set, because in one if we are having elements and in the other it is empty, you cannot form a ordered pair. So therefore it is an empty set. Therefore A cross phi, because B intersection phi is 5, A cross phi is equal to 5. Therefore it is a true statement. It is a true statement. Now the next problem, that is the fifth one, is given as if A is equal to minus 1 1, find A cross A. So you have to find this. So solution for this is, how do we find this? We'll see. If A is equal to minus 1 1, find A cross A. So therefore first we'll find out what is A cross A. A cross A for any non-empty set A, for a non-empty set A is given by A cross A is equal to set of all A, B, C, and here you have such that A, B, C belongs to the set A itself. So now we'll see what is this. So what is A cross A is equal to minus 1 1 cross minus 1 1 cross minus 1 1. This is given to us. So this is equal to, what is the first element you are getting? Minus 1, all the first elements of all the three sets. Then you have minus 1 1, then minus 1 1 minus 1, then minus 1 1 1, then you are having 1 minus 1 minus 1, then 1 minus 1 1, then 1 1 minus 1, all three ones. So this is the way we write ordered triplet. Next. So now you can see here in question 6, if A cross B is equal to A comma X, A comma Y, B comma X, B comma Y, find A and B. So now here in this, the Cartesian product itself is given to us. We have to find out what is the value of A and B. So therefore here A cross B is equal to A comma X, A comma Y, B comma X, B comma Y. This is given to us. So now we have to find out. We know that this is the Cartesian product of, so the above is a Cartesian product of two non-empty sets A and B is given by A cross B is equal to set of all ordered pairs A comma B. A belongs to A and B belongs to capital B. So therefore A is the set of first elements and B is the set of all second elements. A is the set of all first elements and B is the set of all second elements. Therefore here you will get A is equal to A comma B and B is equal to X comma Y. So therefore here you can see that A cross B is equal to A comma X comma B comma Y comma A comma Y comma B comma X. So these are the four ordered pairs which you get in the Cartesian product of A cross B. 7, what you can see, let A be equal to 1 2, B is equal to 1 2 3 4, C is equal to 5 6 and D is equal to 5 6 7 8. Verify that A cross B intersection C is equal to A cross B intersection A cross C, and second A cross C is a subset of B cross D. So now here in the solution part, what do we have? We have to find out first what is A cross B intersection C should be equal to A cross B intersection A cross C. Now it is given that A is equal to 1 2, B is equal to 1 2 3 4 and C is equal to here 5 6, D is equal to 5 6 7 8. So this is given to us. So therefore you will have here, you can write it as this is 5 here. We are given A, B, C and D. We have to find out first what is B intersection C, which is equal to B intersection C is 2 3 4 intersection of 5 6. Since there is nothing common in B intersection C, we take this as 5. Next we have what is A cross B intersection C, which is equal to A cross 5, which is equal to nothing but 5. Next we have what is A cross B. We have to find out A cross B is 1 comma 2 cross 1 comma 2 3 4. A cross B, which is equal to this, you get 1 1 1 2 1 3 1 4, then 2 1 2 2 2 3 2 4. So now you can see what is A cross B. We'll see what is A cross C. A cross C is equal to 1 2 cross 5 6. So which is equal to, you can write it as 1 5 1 6 2 5 2 6. So A cross B intersection A cross, this is 5. Therefore we can see that from 1 and 2 we can conclude that from 1 and 2 we can conclude A cross B intersection C is equal to A cross B intersection C is equal to A cross B intersection A cross C. So this is the first one we got. The second one is we got A cross C is equal to 1 5 1 6 2 5 2 6. This is A cross C. Now what is B cross D, we'll see, because you have to prove that A cross C is a subset of, verify that A cross C is a subset of B cross D. So we are seeing whether A cross C, what is it? It's equal to this. Now what is B cross D? We'll see. B is equal to, what are the elements in B? We can see from here, B is equal to 1, 2, 3, 4 and D is equal to 5, 6, 7, 8. So you get here 1, 2, 3, 4 cross 5, 6, 7, 8. So what is B cross D? We'll see. It is 1, 5, 1, 6, 1, 7, 1, 8, 2, 5, 2, 6, 2, 7, 2, 8, then 3, 5, 3, 6, 3, 7, 3, 8, then we have 4, 5, 4, 6, 4, 7 and 4, 8. So these are all the ordered pairs which we are getting in B cross D. Now we have to see over here whether set A consists of elements of set C. So here you can see that A cross C, you have 1, 5. Is it there in this? We can see, yeah, 1, 5 is there in BD, B cross D. Then 1, 6 is also there. Then we have 2, 5. We'll check it out. Yes, we have 2, 5 here. We have 2, 6 also. So therefore very clearly we can see that the elements of A cross C are the elements of B cross D. Therefore A cross C is the subset of B cross D, hence verified. So now question 8, let A be equal to 1, 2, B be equal to 3, 4, write A cross B. How many subsets will A cross B have? List them. So here in the solution part you have what is given. A is equal to 1, 2 and B is equal to 3, 4. So therefore, and A cross B is equal to, is asking to write what is A cross B. A cross B is equal to 1, 2 cross of 3, 4, which is equal to 1, 3, 1, 4, 2, 3, 2, 4. So which is equal to, here this is A cross B. Now is asking to write down how many subsets will A cross B have, list them. Now A cross, number of elements in A is equal to 2, number of elements in B is equal to 2. So number of elements in A cross B is equal to 4. So therefore here you are having number of elements in A cross B is equal to 4, means now number of elements in the subset of A cross B, how many subsets you will have, we'll just see. So here number of subsets of A cross B is equal to 2 to the power of 4, which is equal to 2 into 2 into 2 into 2, which is equal to 16 subsets it will have. So what are all those subsets? We'll just write down all those and list them also, they asked, isn't it? So the subsets of which set we have read? A cross B. So A cross B is equal to 1, 3, 1, 4, 2, 3, 2, 4. So we have to write down 16 subsets of this. So subsets of A cross B is equal to, first we can write it as 5, the empty set, then in braces only the set where it consists of the first one, then 1, 4, then only 2, 3, then only 2 4, then we have only 2 2. Now we took each and everything separately, so therefore you have 1 2 3 4 5 you wrote down still now. Next you taking 2 together, so 1 3, now 1 3 1 4, this is one set, then you have 1 3 1 5, and sorry 1 3 2 3 you'll have, so 1 3 1 4, then you're having 1 3 2 3, then 1 3 2 4, then 1 4 2 3, then 1 4 2 4, then you're having 2 3 2 4. This till here we had 2 elements. Now we'll write down what are all the 3 elements. So you can write the 3 elements as 1 3 1 4, then 2 3, then next we can write as 1 3 1 4 2 4, then 2 4, sorry 1 3 1 4, we had all these. Next we'll have it as 1 3 2 3 2 4, next 1 4 2 3 2 4, then 1 3 1 4 2 3 2 4. So these are all the subsets of the given set. So therefore you can count and see 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16. So totally you are having 16 subsets of A cross B. Let A and B be two sets such that n of A is equal to 3, n of B is equal to 2 if x comma 1 comma y comma 2 z comma 1 are in A cross B. Find A and B where x, y and z are distinct elements. So now here x, y, z are distinct, you are having 1 and 2 is distinct here, so therefore you can see here how to find out. We have to find out what is A and B over here. So what is given in the solution part, we'll see. The solution, you can see that we have to find out what is A and B. Given here these sets, ordered pairs are given to us. So here we can, n of A is given to us, it consists of 3 elements. N of B is given that it consists of 2 elements, and also we have and x comma 1 y comma 2 z comma 1 are in A cross B, are elements of x1 x comma 1 y comma 2 z comma 1 are in A cross B. So we know that A is equal to set of all first elements of the ordered pair elements of A cross B, and B is equal to set of all second elements of the ordered pair elements of A cross B. Okay, so now here you are having that clearly we can see that x, y, z. See here you can see that x, y, z are nothing but the first elements of the ordered pairs, and also they belong to A. So A is equal to x, y, z, and B is equal to, you can obviously see that what are the leftover elements there, 1 and 2. So therefore 1 and 2 are the elements of B. So x, y, z are from A, and 1 and 2 are from B. So n of A is equal to 3, and n of B is equal to 2, and A cross B is equal to x1, y1, z1, and also having x2, y2, z2. So these are nothing but the elements of A cross B, and you can clearly see which are written over here: x1, y2 and z1, x1, y2 and z1. All are the elements of A cross B. So therefore it's true that A is equal to x, y, z, and B is equal to 1, 2. That is, a number of elements of A is equal to 3, number of elements of B is equal to 2. So this is the 10th problem. The Cartesian product A cross A has 9 elements, among which are found -1, 0 and 0, 1. Find the set A and the remaining elements of A cross A. So now in the solution part, this also has been done in the concepts. I have done this as one of the example. You can go into the description box and see into that, where I have done the concepts of Cartesian products, relations and functions. From that I have done this as one example. So now here, if n of A is equal to P and n of B is equal to Q, we know that number of elements of A cross B is equal to how much? PQ. And now next, n of A cross A will be equal to n of A into n of B. So which is, n of A itself. So therefore here it is obvious that n of A into A consists of how many elements? It's given 9 elements. So which implies that n of A into n of A is equal to 9. That means 3 into 3 is equal to 9. So n of A is equal to 3. So now we are given the ordered pairs are given. The ordered pairs -1, 0 and 0, 1 are 2 of the 9 elements. 9 elements of A cross A. So we know that A cross A is equal to set of all A such that A belongs to capital A. So thus write here -1, 0 and 1 has to be the elements of A, as n of A is equal to 3. So clearly A is equal to -1, 0, 1. And what are all A cross A? We'll just write down. So here we have A cross A is equal to -1, 0, 1 cross of -1, 0, 1, which is equal to set of all ordered pairs -1, -1, -1, 0, -1, 1, 0, -1, 0, 0, 0, 1, 1, -1, 1, 0 and 1, 1. So now you can see that the elements which have been given over here, those two elements, that is -1, 0 and 0, 1, are elements are -1, 0 and 0, 1. So you can see that they are elements of A cross A. Therefore A consists of -1, 0, 1. is the answer. What are the elements of A means this is the answer. And these are also the remaining elements other than minus 1, 0 are the, if you round off these two, what are all the remaining elements are the remaining which are left off after rounding off. That will be the answer. So these are the remaining elements of A cross A.